Hi, everybody. Welcome to Relativity Ask the Expert webinar for regular expressions for beginners. What are they and how can they help me? I hope everybody can hear me and see my screen. Yeah, if a few of you could just type into the chat window that you can hear me. Yes, I'm seeing that everyone is I'm getting a lot of confirmations here. Thanks, everybody. All right, let's get started then. Okay. My name's Eileen Tan, and I am a member of the advice team here at K-Cura. I've worn some different hats throughout my career. I've been a developer, an attorney, as well as a lit support specialist. All right, so before I hop into the agenda, I just want to let everyone know that obviously you can hear me, but I can't hear you. There are lots of folks registered for this webinar. And so if you have questions, you can type them out through the question window, and I'll try to get through as many as I can at the end of the session. And any questions that I'm unable to answer during the webinar, I'll get back to you by email. All right. So the agenda for today. First, we are going to give everybody a high-level introduction to regular expressions, or what are commonly referred to as regex. And we'll do some quick tips on DT search and regex. We'll go over 2 use case scenarios before diving into regex meta characters and demos. And I'll explain what meta characters are in a few slides here. Now, and finally, we'll end with some ending notes. So the heart of the webinar will really be this 4th step here, regex meta characters and demos. What the format of this will be is that I'll give a quick lecture of a regex meta character and then jump into a demo. So it might seem kind of jarring, me jumping back and forth between lecture and demo, but I'll just, honestly, if I just straight out lectured you for an hour on meta characters, half of you are going to be asleep in 10 minutes, all right? So hence the jumping between live demo and lecture. All right, what are regular expressions? So regular expressions constitute kind of an arcane pattern searching language. So even some programmers don't know about regex. So I like to think of it like Latin. It might be a dead language, but still very useful if you understand it. So what regular expressions allows you to do is it allows you to construct a single search string so that you can search across a pattern of characters rather than having to construct a bunch of search strings to get the desired results. So what we need to do this afternoon is put on a different searching cap on. We're going to be focusing on pattern matching and not literal searches, right? So for example, instead of searching for the literal phrase dog or cat and having to spell out dog or cat, we're going to learn how to pattern match and use special characters to bring back phrases that have 3 letters in them, or strings with 3 letters in them. All right. Here are some examples of regular expressions. All right, so everybody, I know this looks like hieroglyphics right now. Don't freak out. It's going to be okay. The goal of this 1-hour webinar is not to teach you regular expressions in an hour, right? Because you can't learn a foreign language in an hour. That's impossible, right? So what my goal for this webinar is to give you a high-level introduction to regular expressions, teach you some of the basic meta characters that are going to help you in your day-to-day searches in relativity. This webinar is being recorded. The slide deck that I'm going through, this will be available to you. We're going to be emailing this slide deck to you at the end of the webinar. And then also the sample data that I'm going to be using in my live demos, that sample data is going to be available to you in a zip file along with instructions on how to upload the sample data, how to build a DT search index. That's all going to be available in a secondary email that I will be sending you. And so in short, I'm going to be giving you the tools for you to practice regular expressions on your own after this webinar. So don't feel like you need to take frantic notes or screenshots, because all of this material is going to be available to you. All right, quick tips on DT search and regex. So real quickly, in relativity, you can use regex in DT search, but you can also leverage regex in your structured analytics sets. Now, for purposes of this beginner's webinar, I'm going to focus on DT search. If you are curious as to how you can use regex in structured analytics, you can sign up for my advanced webinar on December 7th. And for those of you who have heard about relativity and data grid, regex, everything that I'm demoing here and showing you will be available in data grid. All right. All right, so within DT search, you can activate regex by just encapsulating your regex string with double quote, pound, pound, double quote. Very important, there's nothing extra to install. Once you've built a DT search index, you're ready to go, you're ready to run regex searches. So a DT search regex would look like this. And essentially, the double quote, pound, pound, double quote signals the DT search to treat the encapsulated string as a regex. And quick note, symbols can be made searchable by adjusting the DT search alphabet file. I've done so for purposes of this session. We have a great recipe on our help page on how you can make special characters searchable. And just ensure that you have curly, not curly quotes, but straight quotes. Where this is going to come into play is if you're constructing a regex to a client and you're typing in your Outlook and you start typing your double quotes, Outlook's going to turn those double quotes into curly quotes. And when your client copies and pastes that regex with the curly quotes into DT search, it's not going to work. So always ensure that you have straight quotes. This will not be an issue if you're just typing directly into the search boxes in relativity. Finally, never use capital letters in your regex because everything in DT search is normalized to lowercase. When you have done searches in the past in DT search, I know that you've probably typed out capital letters a whole bunch of times and you get the proper results. And that's because we have a middle layer of code that translates all your capital letters into lowercase. But for regular expressions, that middle layer code doesn't work. That's why within the regex string, you need to use lowercase letters. All right, I'm going to go through 2 use case scenarios before I jump into what some of the meta characters are and live demos for each of those characters. All right, when would you use regular expressions? Your case team comes to you and says, hey, we've got documents that contain base numbers beginning with a prefix REL with a padding of 6. This is what they look like. We need to define documents that have these base numbers in the extracted text. Well, you know that if you use a normal wildcard search, REL star, this is going to bring back wildly over-inclusive results, right? You're going to get return relative or relational, relieve, all kinds of terms. But if you understand regular expressions, you can use the single regex here on the bottom, and this will limit the search to hit on only those terms that begin with REL and are followed by 6 digits. Okay, use case scenario 2. This is a more common scenario. Now your case team says, hey, we've got documents that have serial numbers and they all have the same pattern, 4 letters followed by a hyphen, followed by 4 numbers. Here's a list that they give you as an example. Now, if you knew regex, you could use this following search string to bring back all documents that have terms that match this particular pattern. All right. If you didn't understand regular expressions, you would have to construct this multiple terms query, right? NLRT or JLVW or KPAX or so on and so forth. Well, even this wouldn't work. right? If the case team comes to you and tells you, hey, that list that we gave you, that was just a sample list. That was just some of the serial numbers we're aware of. There are many, many other serial numbers. We don't have the entire list, but you need to find these documents for us. In this case, this multiple terms query would not work. You would have to understand how to use regular expressions to get back the proper results. So here we use the one regular expression on the bottom, a single query, to bring back all documents that have four numbers, four letters, followed by a hyphen, and four numbers. All right, let's dive into the heart of this webinar, regex metacharacters. I'm going to talk about commonly used metacharacters. Right. So what are regex metacharacters? Well, metacharacters, these are the building blocks of regular expressions. Each character in the regex, it's either a metacharacter that has a special meaning, or it's just a regular character. For example, \d in a regex is a metacharacter that represents a number. D just stands for the little character D. Now, metacharacters then are, think of chemistry in a periodic table, right? So within the periodic table, you have multiple elements on the table, and you need to understand how to use these elements to build chemical equations, right? But there's no need to, memorize every single element. For the more common equations, you probably just need to know carbon, hydrogen, oxygen, nitrogen, right? It's the same thing with regex metacharacters. I am not going to teach you or show you every single regex metacharacter under the sun. I'm just going to show you the common ones that I believe are going to help you the most in your day-to-day searches in relativity. Now, before jumping into demos, I just want to let you know that some of these demos in the beginner's webinar might not make much real-world sense, but that's just because the purpose of this webinar and the demos is to illustrate the function of each metacharacter. All right, let's look at some metacharacters. \d represents whole number 0 through 9. \w stands for any alphanumeric character. Capital W will bring you back symbols, and the period. The period is one of the more commonly misunderstood metacharacters for beginners, but it's a very, very important metacharacter. This will bring back any alphanumeric character or symbol. And I know this looks like, what are you talking about, Eileen? But once I jump into the demos, hopefully this will make a little bit more sense. How do you apply metacharacters? Well, if you have \d 3 times, you would return the numbers 274. Now, I don't see most of you really going to be using \d or \w very much, but these are some of the very basic metacharacters that I have to show you. What's going to be more important to you are called character sets, which I will mention in a few slides. \w 3 times is going to bring you back either a term like dog, right? Because it's three characters, three alpha characters here, or it's going to bring back three numbers, 274. Capital W 3 times will give you any string of three symbols in a row. And finally, the period. Period is the universal matching character in regex. So three periods in a row, it's going to either give you 274 or dog or three symbols or a combination of the three. And with that, let's jump into our first demo of these metacharacters. Okay. All right. So right in my workspace here, you'll see this is a sample data that I'm working with. Got about 406 records here. And again, this sample data is going to be available to you as a DAT file to load into a test workspace. And for simplicity's sake, you'll notice in the extracted text field, I just have these terms themselves so that we can see the results very easily here. In the real world, of course, it's not going to be so nice and tidy. Now I've got a little cheat sheet here, beginner's regex, which are the exercises that I'm going to step through with you. This list right here will be available to you as a spreadsheet. So everything that you see here, again, will be available to you in a zip file in an email that I will be sending you so that you can practice all of this on your own after the webinar. All right, let's take a quick look at our first set of meta characters here. If I do a search, I've selected my DT search index here. And if I do \W 3 times, I'm going to get dog or cat or the numbers 274 and 836. If I turn these W's into \D's, I'm going to get numbers only, and only where there are 3 numbers. If I change this up to the capital W's, I will get back some symbols. Right, and these symbols I have made into searchable characters within DT search. There is a slide at the end that points you to that recipe I was talking about on how to make special characters searchable. And notice that the % has come back. The % is something that a lot of folks I know need to be able to search for. Okay, if I switch this up to let's go back to \W and make this instead of 3. I want to search for a pattern of 5, and we'll get some different results here, right? We've got 5 numbers here, 5 numbers here, and we've got 5 letters. And finally, let's take a look at the period, the universal matcher. If I do 3 periods in a row, I'll get back 3 letters, 3 symbols, 3 numbers, or a combination. Again, the period is a very important meta character. All right, let's go back to our slide deck. And there are 5 demos in all. All right, let's move into character sets. A through Z, bracketed with the square brackets, is going to match any characters A through Z, 0 through 9 here. And just note that character sets are denoted by square brackets. How do you apply character sets? Well, if I have PAND followed by the character set ORA, that's going to bring me back the word panda, right? Or Pando. It's not going to give you Pandora. You would think it is, but the key with character sets is if there's no quantifier, and quantifiers are something we're going to see in a few more slides, if there's no quantifier at the end of the character set, then regex is going to assume that you only want one of these characters returned. And that's why we don't match for Pandora, because this has 3 of the letters. And this will make more sense in the live demo. If we switch up to numbers, PAND 467 is going to give me PAND 4 or PAND 6, but not 467. All right. And with that, we'll jump into our second demo. Okay. Let me hop into my cheat sheet here. All right. So if I pull up, I'm going to clear my search and pull up a view that I had earlier set up to bring back all of the terms that start with PAND. All right, notice what happens to this list when I search just for PAND followed by the character set ORA. I only get back these results where only one of the letters is returned. Now notice order. Order does not matter in a character set. So I'm going to get the exact same 6 results here if I turn this into AOR. Character sets do not care about order. Groups do, and we'll talk about groups next. I change this up to the numbers. I get 4, 6, and 7. If I take 7 out, obviously 7 is going to drop out. I can put 7 back in at the beginning, and again, order does not matter. I get panned 4, 6, and 7. So that's character sets. I envision that you most likely will be using character sets a lot. All right, jump back into our PowerPoint. We're moving right along into groups and alternation. Now order will matter. So the character group ABC, this is surrounded by parentheses. This will match the characters ABC in that exact order. Alternation, so the pipe character in regex, the pipe character is equivalent to the Boolean OR, right? So if I have parentheses ABC, pipe 1, 2, 3, this is going to match the characters ABC or 1, 2, 3 in that order. How do you apply groups and alternation? Well, now if we have PAND, group ORA, now we'll return the word Pandora. And if we have panned 4, 6, 7, now we're going to get PAND followed by 4, 6, 7. If I apply the pipe character, I will return Pandora or panned 4, 6, 7. All right. Obviously, I must have been listening to Pandora while I was making the slide deck, hence all these references to Pandora. All right, let's jump into a demo of groups and alternation. Okay. Now I'm going to stay on my Panda view here and clear the search. Watch what happens to the list when I do a search for this phrase, panned, followed by the group ORA. Now I will get Pandora exactly. Now if I switch up the order here and make this OAR, I'm going to get most likely 0 results because I don't think I have any terms in here that match this exact order, and I don't. So again, order matters with character groups. If I change this up to 4, 6, 7, you'll see I get the exact terms, 4, 6, 7. Character groups, I see everybody, I do get one result here. I see most of you are going to be using character sets with the square brackets. You're really not going to be using character groups very much because obviously why would you do that if you could simply just search for just pan 764, even without a regex. But it's an important concept that I need to show you nonetheless. Character groups may come into more useful in advanced searching with structured analytic sets. All right, now I'm going to apply my alternator, and then watch that I will bring back both these results, Pandora and 4, 6, 7. Okay, let's clear this search and go back to my demo, my slide deck here. Quantifiers. All right, we're down to the last 2 demos here. We're doing very well on time, so if you do have any questions that you've thought of in the meantime, feel free to type them down in the window. We'll most likely be able to get to them. All right, so quantifiers. Quantifiers are very, very important. I'm going to introduce you to 3 of the some of the more commonly used quantifiers. So squiggly bracket n is going to match where the preceding character or group occurs n times exactly. And again, this will make more sense when I jump into the application and demos. N and m is what this is going to be able to allow you to range match at most n times and at most m times. What does this look like? So if we have panned followed by the character set ORA followed by quantifiers at least once, at most twice, this is going to give me back terms such as panda, matching once, pand R twice, and pand do. Notice that you can have the same character return as long as it's within the character set and it appears within the range that is specified in the quantifier. If I apply the quantifier to a character group, you'll notice that here now I have Pandora at least once and ORA at least twice. Finally, if we apply this to a serial number, NLRT-4679, this pattern is what's going to be brought back by this regex here. 49677, we have 5 numbers within this character set that appear 5 times, which is within this window here. And the same for this character group. 4679 appears at least 1 here and at most twice here. All right, let's jump into a demo of quantifiers. All right. So let's see which one should we do first. Let us do this one right here. All right. So what this is going to do is it's going to bring back all terms where we have ORA that follow PAND, and ORA appears at least 3 times and at most 8 times. But you know, obviously the letters can appear multiple times as long as it's within the character set. All right. So you'll notice I have call-outs here for you to practice certain one of these combinations. All right, so let's look at a character set with a quantifier versus a group with a quantifier. So here's the group. What would I expect, right? I would get ORA and ORA twice, but if I change this up to, oops, wrong. If I change this up to be a character set, I'll have completely different results here, right? I will not have ORA in a row. However, if I change this to 3, now I will get Pandora, but that's not because I'm calling for ORA directly here. It's because these 3 letters are in a character set. Let me change this up, and we get the same results. All right, so that's quantifiers in a nutshell. All right. So we're going to get into the last 3 quantifiers here and a quick demo. These 3 quantifiers are very important. I'll have a separate page for each of these. So the question mark quantifier, what this is so the question mark is going to allow a match when the character preceding the question mark occurs 0 or 1 time only. Now, what does this mean? Basically, the question mark is making the match optional. So what does this mean in an application? Well, if I have color and I insert the question mark after the letter U, basically what this is doing, the question mark is making the U match optional. So this regular expression is going to bring back color where U is found 1 time, or it's also going to bring back COLOR where U is found 0 times. This will be very useful, for example, if you're searching for zip codes, and we'll get into a demo of that. So again, the question mark is 0 or 1 time only. 0 or 1, not 0 or more. The plus quantifier, another important quantifier. The plus sign matches when the character preceding the plus matches 1 or more times. So this is making the match mandatory. What does that look like? All right, so if I have TRE, and I'm using E as a character set here to make this more clear, and this is actually how you would want to apply this in DT search and also in structured analytics. TRE with the plus sign, tree is going to match because E here is found after TR 2 times, so 1 or more times, right? Twice. We're also going to match for TRE because E is found 1 time here. But we're not going to bring back TR because E is found 0 times. So the plus sign makes the preceding character or character group mandatory. So this would be helpful if you're looking for zip codes, for example, and the case team tells you we only want zip codes returned where it's a full zip code or something like that. All right, now the star quantifier. What this is going to do is it's going to match where the character preceding the star occurs 0 or more times. This is the most commonly mistaken quantifier in regex because it is not what you normally would think of as what the star does. The star by itself is not equivalent in regex to the wildcard star in a regular DT search. So let's see what I mean by that. Here, TRE star, we're going to match for tree because E is found 2 times after TR. We're also going to find TR itself. E is found 0 times, right? So 0 or more times. But we're not going to match for trees because E is found twice, but this fails to match because the S is not accounted for in this regex. Now, how to equate the regex star with what you normally would think of as a wildcard search? Well, here's how. The combination of the universal character matcher, the period, and the regex star is what gives you what you would normally think of as a quote-unquote normal wildcard search. So TRE period star is going to return TRE, trees, treadmill, treble. So TRE period star is equivalent to TRE star in a regular DT search. Why? Because the period, this matches for any character, and the star makes the period, any character, match 0 or more times. Now, everybody, I know this is a lot to take in, but I promise if you just practice using this slide deck and the sample data that I'm going to be giving you, this will start making sense, right? Just like with any foreign language, practice makes perfect. All right, so let's jump into our final demos here. All right, I'm going to clear this search. We'll start to see some more real-world examples in my last demos here. All right. First, let's take a look at the question mark. All right. So the first one, this is just going to bring me back. Text that has what I call regular US phone numbers with the 3 numbers, right? We got 3 numbers followed by a hyphen, followed by any 4 numbers within the character range of 0 through 9. Now, I want to bring back phone numbers with or without the area codes. So in this case, the case team will tell you, hey, I want to bring back any documents that have phone numbers, US phone numbers in them, but they may or may not have area codes. What you would do is put in this question mark quantifier at the very beginning to make the zip code optional. Of course, you could also, do an or here and literally type out this phrase again without the question mark. But why go through that extra hassle if you understand the function of the question mark? If I do a search, you'll notice now that I return phone numbers with or without area codes. Okay. All right. Now let's take a look at zip codes. All right. So this, I know this looks ugly, but again, with practice, this will start looking like normal English to you, I promise. If I click on search here, I'm going to bring back US zip codes that have two letters followed by either the 5-digit zip code or the full 9-digit zip code. Notice I have the question mark here at the end. If I take that off, then I'm only going to get the full zip codes. All right, I'm going to put that back on. Okay, so very important to note, regular expressions within a DT search, it's just another way to search in addition to proximity searching and Boolean searching. DT search sees this as just another phrase, but it interprets it as a regular expression. What I'm getting at is that you can use quote-unquote normal searching with regular expressions. So in this case, for example, if the case team tells you, well, hey, it's great that you're bringing back all these documents, but I'm only interested in Illinois. Great, that's all right. You can just say Illinois here, or you can say Illinois maybe within 2 of a zip code. And this way I bring back all Illinois zip codes. Or you can say, and now if the case team tells you, well, I would like to see Illinois or Virginia. You can use a regular expression to do that. Now I bring back Illinois or Virginia zip codes. If I take the quantifier off, then I bring back only the full Illinois or Virginia zip codes. So that's a review of character groups and alternation. Now, if you wanted to do, if you didn't remember how to do that, you would have to type out Illinois here or Virginia to get the same results. So that's just to show you that you can mix and match regular expressions up with proximity searches and Boolean searches. So I got a question here that asks, why can't you use a space character? So notice how I've got spaces here between Illinois and the zip code. Let's simplify this down to just Illinois. This is a very good question. Why can't you just use the space character here? So for example, why can't you say Illinois \S is the meta character for a space character in DT search. Watch what happens if I try to use a \S. I return 0 results. Why? I return 0 results because within a DT search index, spaces do not exist. There are no such thing as spaces in a DT search index. Any space that you see is translated into a word break. So that's why a \S will never work in a DT search index or in the DT search. And similarly, let me show you. Okay, I'm going to go back to one of my. So the takeaway there is this: that never go down the path of trying to match for a space with \s, that will never work for you. All right, let me do, since we're kind of onto questions now, I'm going to just take a quick detour here and show everybody what I mean by capital letters not working. If I turn this first part into capital P-A-N-D, I bring back 0 results because that middle layer code that changes capital letters in this search box to lowercase letters doesn't work with regular expressions. So always be careful that you are using lowercase here. And even though within the extracted text there might be capital letters, when it gets into the DT search index on the back end, everything's normalized to lowercase. All right. And I have another question here that's asking, does DT search allow for escape characters? Yes, we will get that. We'll get to that in a slide shortly. All right. We're still doing okay on time. So let's do a couple more examples of these quantifiers. I want to get through at least the last 2 quantifiers here. All right. Let's do the plus quantifier. This is going to bring back exactly this pattern for letters, hyphen, for numbers, hyphen, for letters, for numbers. So if a case team needed to search for that, for serial numbers here, this is what we're going to get. Now the case team throws you a curveball and says, you know what, we're always going to have 4 letters and this hyphen and 4 numbers, but you know, sometimes this might be A, B, C, D, E. Sometimes this might be 6, 3, 7, 8, 9, 10. Shoot, what are you going to do now? Well, what you can do is then use the plus quantifier and turn each of these, what I would call hard quantifiers, change these up into pluses. And remember what's the plus going to do? The plus is going to make the preceding character set or group match 1 or more times. So this is very helpful for if you have, like, you know, a whole bunch of maybe hyphens that you're trying to match for, or you don't know how many hyphens there are. Well, put a plus in front of the hyphen. Now this is going to give me the same pattern, but it's allowing for different sizes of each string here. Notice we've got this extra long string, but it still follows the same pattern of letters, numbers, letters, numbers. Got another question here. Can you do a boundary search with a \b? So if you wanted to do a \b, the answer is no, and this has to do with boundary. Just again, like spaces don't exist in the DT search index. All right, now let's move on to the last quantifier. The star, everybody's favorite, the star. Okay. So if I just do PAND by itself with the star, all that's going to do is it's going to bring me back, you know, PAN or PAND, all this. But if I want to emulate what a regular wildcard star search does, I simply just need to input the universal character matcher, the period, and I get these results, these expected results. Anything starting with PAND followed by any string of characters. Got another quick question here. Some of these questions are a little more complicated, so I'm going to have to get back to you individually over email, and you know who you are. So I'm not ignoring you. I'm just going to have to get back to you individually by email. And I do have everyone's email addresses, so I can see who's asking the question and your email address. Another quick question here. So with regular expressions, can you search for credit card numbers without auto-recognize set to yes? That is correct. With regular expressions, then you can just search using a string, using a string something similar to this, and there's no need then to turn auto recognize credit card numbers to yes when you're building your DT search index. All right, let's finish up our slide deck. And again, if I've lost you, or if you're like, what is Eileen talking about? Again, don't worry. You're going to get the slide deck. You'll have the sample data, and that cheat sheet that I was using to show you the demos, you'll have that in spreadsheet form. Escaping meta characters. So this goes back to a question posed by someone earlier. In short, if you have to search for a character that's a reserved meta character, you just need to use the backslash to escape the character so that it can be recognized as its own literal character. What does that mean? So for example, right here, if I have to apply a regular expression to search for, maybe UK phone numbers, and I know that within the UK phone number, there's the plus sign that I need to search for as well. When I'm writing out my regex, I simply need to put a backslash in front of the plus, and what that's going to do is it's going to escape the plus. It's going to free up, basically, it's going to free up this plus sign so that it's not recognized as the plus quantifier and allow it instead to be recognized as the literal plus sign. So in this case, plus 044 is found. Same thing with a dollar sign. And yes, dollar signs can be made searchable in DT search. If I escape the dollar sign, I will be able to bring back terms such as, $27 or $44 because this character has been escaped. Now here, if I don't apply the backslash, then I'm not going to find plus 044 because then the plus is treated as a meta character. All right, some ending notes here. When would you use regular expressions in your day-to-day searches and relativity? Social security numbers, serial numbers. You can search for any combination of serial numbers, right? Phone numbers, US, UK, or any other country's phone number pattern. Patent numbers, Bates numbers, bank account numbers. The list goes on and on. So really, any instance where you're attempting to search for a specific pattern, you can use regex. You don't need to ask the case team, hey, case team, I need like the entire list of numbers you need to search for. No, you don't need that. You can just construct the regex to bring back the terms. The only caveat I have is if you go the regex route, persistent highlighting or highlighting does not work. That is on the roadmap. Hopefully we can get that going at some point. But for right now, what happens is the documents containing the terms are returned, but these terms themselves are not highlighted when you actually click on the documents. So some resources here. This is the link to that advice regex recipe, which the top half of which shows you how to make special characters searchable in DT search. This regexer is a very cool and free regex tester. You can test your regular expressions here before applying them in relativity. And also, this is a deeper dive into regular expressions. And how I would recommend that you practice on your own is that you'll build a workspace, obviously, and then when you maybe have, I would for example recommend that you build some extra empty records. And what you can do is if you wanted to enter in more test data on your own, you can simply click on edit on an empty record. Have the extracted text field or whatever field that you've indexed in your layout, have that as a field that you can edit. If I can get this to load, I can show you what I mean. So here I've made a layout called extracted text editor, and I can simply, start typing in some, test data to match for here. So that's just a quick and easy way of testing, inputting records to test on. So if your case team has specific strings they're trying to search for, just enter a bunch of strings in here. So that is how I normally go about testing my regular expressions. So you can do the same. All right. And with that, I'm going to, for those of you who need to, go about finishing up productions, and if you don't have any questions, definitely feel free to jump off. Again, I will be following up with everybody with one email that contains this slide deck, and then a secondary follow-up email with the sample data attached. But for now, if I can try to read through some of the questions that have come in and answer them live here in the remaining 8 minutes that we have. All right. And there's one question, can you use any of the quantifiers more than once in a search string? Yes, you can certainly use quantifiers more than once in a search string. And you can use different quantifiers in a single word. Yeah, you can place a quantifier anywhere you want through your search string. All right. A couple of questions about escaping characters, which we've already answered. And here's a good question. So if you have, okay, and this one I am going to put up on the screen here. This is a very good question. All right, so the question is this. I'm going to go back to my zip code example. All right, where are you, zip code? There we are. So think of each regular expression as a phrase. It's just another phrase, right? I'm going to take off the question mark to make this more, just so it looks a little bit better. So for example, this is a string or a phrase, and this is a string. So this could be literally, if I'm searching for the exact phrase dog, cat, right? That would look like this, dog, cat. That's not dog or cat, right? It's just literally dog, cat in that order. It's the same thing for regular expressions. So here, we're literally telling DT search to bring back 2 letters followed by these this pattern of numbers. And the question is, so what if you switched up the order? Would that probably won't bring back this pattern then, right? That's correct. So now we're asking for, the numbers in front of the letters, and I'm going to bring back 0 results. All right. Let's bring that back. And again, right here, this space here, right here, that is a word break in DT search. It's the same whether you're talking about a normal search or a regular expression search. Any spaces that you see in relativity is a word break. All right, let's take a look at a couple more of these questions here. And yes, you can use normal DT search syntax combined with a regex. So if you wanted to do, for example, here within 2. Whoops, sorry, this mouse is not cooperating. You could do that. And also, let's, if you wanted to say, or and, you could do that. Proximity and Boolean searches can be used with regular expressions. So think of it this way. Up until now, most of you have probably been using proximity searches and Boolean searches in relativity DT search. Regular expressions is just a third tool a third way of searching that you can use, which has always been here, but which just hasn't been publicized very much because, like I said, regular expressions is a dead language like Latin, but it's still very, very useful. So again, there's nothing that you need to do to install or anything like that, right? If I just look at my DT search index, it's a normal looking index, right? There's nothing extra that I did here. All I did was build this index, it activated, and then once I had this active index, I could just start writing regular expressions against my documents. All right. And there is some more complicated questions here that I will get back to each of you via email. All right. So yeah, so just remember this in DT search. I know we have fuzziness and all that, but I want to keep this simple. So in DT search, we have proximity searching, right? You're using your within to. We have our Boolean searches or and, and not. And then finally, you have regular expressions. You can use all three of them together. So I can say, for example, here, and not, which is not going to work, so I'm not going to hit enter. But yeah. All right, everyone. So we have a couple of minutes left. And some of these questions, again, are more deep dive, so I will get back to you individually. And remember, if you're curious to see how you can leverage regex with structured analytics, you'll see how I've got some examples here of using regular expressions to filter out text in my email threading or near dupe sets. If you're interested to see how that works, please attend my advanced regex webinar, which will be conducted on December 7th. And you can sign up for that the same place where you sign up for this webinar. And you'll also have sample data that I'll give you for that webinar, and also the cheat sheet here that you see that I'll be using to demo that webinar. And yeah, and actually, if for those of you who requested, I can also send the advanced regex solutions to you, but I'm trying not to send that to everybody because I would really encourage that you attend the webinar before trying any of these solutions. As you can see, it gets kind of crazy looking here, as you can see. Okay, everybody. Well, that brings us to the end of this Ask the Expert webinar. I hope that was helpful for everybody. Look out for emails from Kate Cura with the slide deck, and then an email from me with a zip file of the sample data. All right, thanks, everybody, and I hope you have a great rest of the week.